A. Now, how do we put that in? Yep. How do we put that in? It's a very William Mawan.
The functions,
A.
rules in the application.
Can it?
Statistics.
A. I get body or give. Go for a can sit my Nandima Cap office. A. Operating system. On the practice. A. The calculator also so I understand. Oh, no, much as I calculate.
It's going to fail.
None much as a calculator. A. Right, I can share this variance. Le standard deviation. When you don't try with Christy, accommodate house. House in Hawaii, on answer the CEO. And then it reads away the measure. In fact, Hariri, the measures of central tendency. The measures of central tendency in the mean, in the median, and the mode. Those are the three fundamentals, the three measures of central tendency. Calculate or give us the three measures of central tendency. Come on, the mean, the median, the mode. Now the question is now to say three about the mean, the average of the data set where you take the individual numbers, you add the sum and then you divide by the total number of the elements that are in there. And then get such things. And then the median where you arrange your data in ascending order. And then from there you look for the middle value. Okay? If there's no middle value, if the data number totally even, you take the first two, then you divide by 2. Whereas if it is odd, there will be a middle. A. What the plus and then we divide by 2. The sum here. Remember, on a similar videos that you posted, link so that you can go through that. And then a mode, the one that appears most. Maybe 3 4 1 therefore we will take 3 as the mode of that data set. Right. And then in this measure of central tendency, it provides information. It provides information. It provides the information on the data. On the data values at the center of your data set. And then we are therefore saying the measures of dispersion. The measure of dispersion, in those measures of dispersion, repeatedly quartiles. Lower quartile, upper quartile. Those are what we call the measures of dispersion. Quartiles, and then percentiles. And then lastly, ranges. Range, where we said now the range. You take the maximum, you subtract the minimum, and that becomes the range of your data. So a measure of dispersion, quartiles, upper and lower quartiles, come on to Q1 and Q3, percentiles, and then ranges. Unfortunately, we haven't dealt with this. Maybe or calculated 80% or whatever percentage of that data. We haven't yet dealt with the percentiles. And then we still have two more. We still have 2 more measures. 2 more measures of dispersion, which we call the variance. Variance maobane. E bitswang variance le standard deviation. So come on, Jomang, and like maobane, we dealt with quite a considerate number or a considerate information, because many of the things is about body quartiles, body range, variance, standard deviation. Maobane, we dealt thoroughly with that. We even introduced the formulas that revolves around that, where we said now variance, right? That sign is so. The variance squared equals the sum where I equals 1, and then we took the square root, not the square root, xi minus median, and then you square that. Okay? This is the variance. Okay? And then the standard deviation will be the square root of that, where you are taking exactly
xi, the number of the data. I get a accelerating
energy mean, and then xi the individual elements that you are provided with. Maybe the first number we minus from the mean, and then in standard deviation will be the square root of that. I get something like this. Verify or whether I don't want this. Those are what we dealt with, and then whenever I verify, I calculate, I wanted to check whether our answer was correct. And then we just revolved around that. We just revolved around that. When we looked at such things.
Question 2, question 2.
Okay. We skip because never at least reveal more information, because in a different in a different so we give a so corner the level question 2 more calculating more frequency and all that. That is what we will be dealing with, right? So the two more measures of dispersion we also are called the variance and standard deviation, which is a topic that we also dealt with maobane. Right, now let us try to define the variance. If we try to define the variance, we're going to say, okay, let a population, as an example, we are looking at this in terms of a population. Let a population consist, let it consist of n elements. So come on, we can say an infinite number of people. N stands for whatever number of the people that you can find within a particular vicinity. Okay? And then we will represent that maybe as x1, x2, and so on, to whatsoever number there can be. So we write the mean. Because the first thing that you will need whenever you calculate the variance, you will need the mean of that data. That is the first thing. Now we write the mean of the data as this. This will denote, or it will depict the mean. To say you are adding the total number of elements divided by the total in fact, more what you are doing, you are taking the individual elements, you are adding them up, dividing by the total number of those elements. Maybe there are 20, 30, 70 elements in your data set. Okay? And then from there, how can you calculate the mean? Come on, the variance of the data. The variance of the data is the average. This is the average squared. This is the average squared distance between the mean and each data value. Now I think need have a ball. variance equals ni equals 1 xi minus x bar squared. So when we say that the variance of the data is the average squared, yeah, this is the average that has been squared, distance between the mean and each data value. So regularity n divided by n. Liberty divided by n more. So the variance of the data is the average squared distance between the mean and each data value. So come on, higher average, you have to divide by the total number of elements because that's how you find the average. So come on, the variance of the data is the average squared, average, but it has been squared. Distance between the mean, the distance between the mean and each data value. The distance, or now when mean distance from each individual element there is. Come on, that variance is what now? It is the squared distance. Variance. Get the definition here already. Or the variance of the data is the average squared distance between the mean and each data value. Each data value is substituted by morbonang xi. The substitute that individual data value.
Over energy is the number of
Average. Again, remember mona renze ma one. Renkani number tani ka fela ka tari fumana bere divide ka n. Energy, how many elements are there? Maybe 7, maybe 8, maybe 9, maybe 10. Again, ma one they calculate them to individually. So nse kere mfe number ya pele maybe kite 20 minus 50.5. Bere square again. Bere ya bube jwalo mfe jwalo and then how to calculate in the variance. Camera variance the renka the square root again. In the standard deviation. Carry mawan. Ranchuna elegantly the square root of ni equals 1 rare xi minus x bar squared. And then in the divide n. Mawani in Nalwe. Vincent Tree. Yesterday, having 20 is standard. Agasilisa. How divided any no, when you saw the Marians, because never saw this book. We are Variance money. Hey, Bo, what you got?
Standard deviation.
I call land about country. Land about variance. We had to divide by n because that was the formula already that came from your textbook. And yeah, no man house.
Hey, this is a formula standard deviation. I think a variance. A variance translating what's in a field. I don't know the terms and go and some of the character into the variance equals to 4,100.
Lecha, the camino divided by n. They will go choose. Right, Harap Kalefilimo. I tell you, Monava, Kadinga individual, I get Fumana Kitchen and Divinity. Harap Kajarabata in variance, I get Haraki in variance, coming any number. Then you divide this by n. Mona in a case square root, standard deviation. Maraka variance, we should have divided this by n. Ilimbogai 9. I divide
9 is standard deviation.
A Mona is standard deviation, but I variance. I want to just be a how more. Oh. Hey. I'm on the money 41,72. So how do you divide them? Kappa one way thing. Hey, I can come out divide ka a nemo. How about a variance? My family doesn't get this book in your house. I divide ka n. I will pause. Number ya re fumane ha o qeta o add di number tse kaofela. Total number ya 4000 what eo. Ka mele re divide ka total number of elements e leng 9. Ha re divide ka ma 1. Nna la mmakatsa. 460. Why what?
56.
How say divide e kae? Sky divide. E kae 4172. Mona ke standard deviation. But variance ya batho mo bile le phoso e tsaetseng. Hell, linna ya o tsebe ke ile ke nana la semola lona mo. Magere copy.
What's all it? Mo aga qetella variance. Aga qetella. Ba bani aga yetsa. Re fan tuna. That's the answer mo le still re feeling answer tuna. Ka bani re mo tse le tjena. La re ke ya re substitute ka mona ho di in trade for 2022.
This one yona e correct. Ne?
O lo ga qetella
Come on Zoma, it is impossible because that formula generation bile ringa textbook nya ha. Batho mkena na yona le ntse import. Ka copy le formula hantle le lona maobane. Ene le tje ka textbook. Aka calculator eng, aka calculator these numbers. Mona bontshitse textbook ya hao. E ka o tlile.
Facebook mo ne mo tse jwalo.
Ona mo nka se ngole ka mokgwa mo tsenga teng textbook le khale kheng bathong. Mare he na he bathong. Ha rena boikgethelo. You must divide by n. Ha re ya problem ya maobane. Re clear ntuna mfe data set. A ke go khutlele problem ya maobane wa ntse. O ko mfe data re ilukise ntwe. Bana jole ke pause e serious. Re tlo lo yetsa le ba testing ya usane.
20.
Ne kopa o mfe data 20 28 36 41 62 69 75 75 80. Perfect. Now have a clue mona re batle variance. A get ha re qale pele ka mean. Kana o itse mean ke bokae? Mfe mean.
Meaning
54 kapa 55 54 right. Ke gona bana he ra tlo xi minus x bar squared. I get ha re ngeno re qalang re 20 in fact 20 minus 54 ne se le di fumane di value tse. I get di value ne le 1156. I get ke batla go fila ausuane aska la hle mfe ya bobedi e tlo ba 28 minus 54 that is a squared. Mfe number mfe answer ya hao ko ga batla at least a catch up nya lona le se di motse ke batla fela ka ga 676 mpe 36 minus 54 that is a squared. 324 mfe 41 minus 54 that is a squared. 100 mpe 62 minus 54 that is a squared. 64 mfe 69 minus 54 that is a squared. How come this value eba kholo go 69 because we take 62 minus 54 is 64. How we square? So when how come 69 minus 54? Because value khulu on pause so it's
Yo.
You didn't mention 324.
Bon 62 minus 54. Ki 64 again? Njui. Kyo. 69 minus 54 ke bokae? 225. Mphe 75 minus 54, that is a squared. 441. Lea bobedi ntse tlo fana ka 441. Ya o qetela ke 80 minus 54, that is a squared. 676. Berereng ha le mo. Nelele di number tseo kaofela. 1156 plus this plus this plus this plus this. How do you add kana do guy?
4172.
4172 again. Now how do you formulating here? Hello formulating variance elegantly the sum of how many terms? There are 9 terms. Ene ya bona ke 9. Re start at the first element limbo guy 20. Then from there renali ngwanona umo edile ka ofela fela ngwanona ka udimo. We itse value ke bokae? 4172 again ngwano ha ka tla mo etsang go mo divide ka eng ka number of elements le bokae 9 o fa bokae ngwano
If 4172 over 9, how many sides is D? 463.56
as the value of the variance. Then how you the standard deviation? Then the square root. Samtwe. Simple. Because bon, the cut calculate and twe. Ntwena ka fela A. Se ri patela fela se re kinya fela eng square root. Mphe value.
21.53.
Standard deviation. So my question go on number 1. How was it possible?
The problem go.
What? Refelletse mo. Hara divider but how ya mo standard deviation kailo kona pause. Also ya 53 pause. It's serious. Jwang ka pa jwang bona re tswa kae ke batla understand the formula e re tswa mo re ntse nthwena kaofela e ke mo then se re kenya fela square root sa nthwena kaofela re qeta mo e etsa then re fa standard deviation. This is highly and highly important ke batho, highly and highly important and jwale ka re boto it is e tlo mbata hore ke phumole o fa chance ya o kho ne butlwe ka something.
Yeah. Beverage.
Variance has the following properties. It is never negative because how did we find the variance? We squared whatever number that we find. We take the first element, we subtract from the mean, and then we square that. Even if we want to answer negative, but any number negative squared will always give you a positive number. Hence we are saying that the variance, it is never negative. It is never negative. Since every term in the variance sum is squared. It is squared and therefore it is either positive or 0, because we can have the same element being equal to the mean, and then when you subtract the 2 you get 0, and 0 squared is always positive. Therefore we are saying the variance, it is never negative, since every term in the variance sum is squared, and therefore it is either the answer you will find more, it's a positive, or it is either 0. The case more in 0, ke ha the element illegally the mean, because when you subtract those two and you square that, you will always get 0. That is the first property. Yeah, the variance. You should never calculate the variance with any negative. It has a squared units. We've only. It has a squared units. And then wherever, since the population in the previous example that we spoke about, let the number of elements represent the population. We are therefore saying, since the population variance is squared, it is not directly compatible is never directly compatible with the mean or the data themselves.
It is never directly.
Again, where it has a squared units. Again, since the population variance is squared, it is not directly compatible with the mean or the data themselves. And this is
Moki, and therefore either incapable.
And therefore, it is never negative, since every term in the variance sum is squared, and therefore the answer will either be positive or will either be 0. In the data set, only the first element is 20. A minus the mean 50.4. Whatever you get more will be a positive number, even though this number more, how is that this subtraction? It's not for negative, but negative squared will always give you a positive. Yeah. Or it will be 0 if the elementary buangayon, it's exactly equal to the mean. Then in this case you get 0. But it shall never and ever be negative, because it has been squared. Like about negative, when you square a negative number, you always get a positive answer. This is exactly what we are saying in the first statement. In the second one, we are saying that it has squared units, or variance. The sum ni equals 1. We have xi minus x this squared divided by n. So we are saying it has a squared units. And then in the example of population, since the population variance, suppose this is the population variance, is squared, it is not directly compatible with the mean or the data themselves. Come on, you cannot compare it with the mean or the data itself. It is not compatible. Or you cannot use the data itself, let the mean to try and make a comparison with the variance. It will never work. Okay? It will never work. But maybe there are some cases where a debate can be thrown. But for now, enough said that it has squared units, as you can see. Since the population variance is squared, it is not directly compatible with the mean or the data themselves. Come on, the individual elements that you find in your data sets. It is important to have a moladinto so that you understand better exactly what we are talking about. Right, right, those are the only two properties that you should know about variance. Now, how will I show us standard deviation? ha o sheba di-properties tsa standard deviation re reng we ra tseba. Let's start first by saying let a population consist of an element. Those elements are x1, x2, xn, and so on. Okay? Right, and then a ring with a mean, because re ka se bue ka standard deviation, hape re ka se bue le ka variance without talking about the mean. Okay? With a mean of x hat, right, ra tseba hore the standard deviation
The first word.
let a population consist of an element. The standard deviation of a data set, it will be given by the formula. This is equals to the root. You have the sigma. By now you understand what that means. And then you have xi minus x this, that is being squared, all be divided by n. Right, we are saying the following. We are saying that in statistics, the standard deviation abbreviated SD is a common measure. This is a common measure of dispersion. So come on, Jomang, in statistics, whenever you calculate the standard deviation, you are in fact calculating a common measure of dispersion. And we looked and explained what dispersion is before I erased on the board. We already dealt with that. Right. Here's in standard deviation. It measures how spread out the values in the data are around the mean. So it measures how spread out the values in a data set are around the mean. So this is exactly what it does. The standard deviation measures how spread out the values in a data set are around the mean. This data set is spread out to Juan. How? Around what? The mean. So you look at the mean and then you compare with how the data has been spread out. And then that's what we call the standard deviation. It measures exactly that. And then to be more precisely, it is a measure of the average distance. It is the measure of the average distance between the values, of the data in the set and the mean. That's exactly what it does. It measures how spread out the values in a data set are around the mean. And to be more precise, It is a measure of the average distance between the values of the data in the set and the mean. And again, this is the average. So come on, by introducing the square root mode, we are in essence measuring how spread out the values in a data set are around the mean. Right? But to be more precise, it is a measure of the average distance between the values of the data in the set and the mean. That's what it measures. Maybe there can be a theory question saying, when explain how the data is spread out. You need to know how to explain that. In terms of what? In terms of the variance and also in terms of standard deviation. That is why we are studying the properties. The properties, see, come on, variance is a standard deviation, so that you can explain whenever there is a wording that needs to be employed whenever you explain the data the way you want to. And that data will only make sense if you understand your now data is wrong, and then what is the value of your variance and your value of standard deviation. Then you can how that data is spread out. And then one of the skewness, right, a skew to the left and skew to the right, to show now whether around the central mean, where's a longer data, is the data symmetrical, kappa skew to the left or skew to the right. And then we also corrected the problem it is skewed to the right, whereas it was not. I remember the calculation of mana will know this is skewed to the left. SD in standard deviation is always positive. It is always positive. Standard deviation is always a positive number. It is always a positive number, and in the same units. In the same units as the original data. As the original data. Eh, but you can have Korabas. The standard deviation is always a positive number, and it is in the same units as the original data. If you are given the original data, maybe to the height of learners in centimeters, you will calculate standard deviation also in centimeters. How can you find a value? You have 43 maybe 0.45 or in centimeter units. It takes the same units as the units of the data set that is provided. Come on, Tomam, it is not just a number. It has SI units. Kahan, ane ko pala tinta. Eh, makot mani. Osha kumatay ma. Ito. Batong kahan tagat. Me. Ito ma. Langanis. Wena. Tumi. Lena la tangi lena le tang formatat. Unkos. There gawuto. Ay gawuto raiko. Langanisa. Utu ukopa-kopanye. Dintuni behan. Okay, haunata. Right, haunata. The last property, okamine mwezi. Kyori nsketeket. Kyori the mean. The mean the mean and the standard deviation of a set of data are usually reported together. They are usually reported together. So come on, drama. You cannot give us the mean without telling us the standard deviation. Whenever we represent the mean, you must also account for standard deviation. They are always reported together. Come on, in a certain sense. In a certain sense, the standard deviation is a natural measure. This is a natural measure of dispersion. If the center of the data, is taken as the mean, statement is the mean and the standard deviation of a set of data are usually reported together. That's fine. In a certain sense, the standard deviation is a natural measure of dispersion if the center of the data is taken as the mean. What do we mean by that? By saying, in a certain sense, the standard deviation is a natural measure of the dispersion if the center of the data is taken as the mean. If we allow that the center of the data is the mean, adding all those numbers Q2 in terms of a box and whisker, so that we explain until we gonna. On a Q1, on a Q2, that is skewed to the right. On a Q3, on a the minimum, on a the maximum. The standard deviation and the mean are usually reported together. In a certain sense, the standard deviation is a natural measure of dispersion if the center of the data is taken as the mean. How do we take the center of the data as... Yes, how do we take the center of the data as the mean? If we are saying we have a data 20, 20, 40, 60, 80, 80, 100. We are taking the center of the data as the mean. Okay? We are therefore saying the standard deviation is a natural measure of dispersion. How is that making any sense? In a certain sense, the standard deviation is a natural measure of dispersion only if the center of the data is taken as the mean. How do you take the center of the data as the mean?
Q2
because Q2 as mean. Q2, give me the Q2. It has nothing to do with mean. Meaning you add all the sum of those numbers, then you divide by the total number of elements. That's how you find the mean. So in terms of a box and whisker, I don't from Tata because box and whisker, how do we work a mean? How do minimum?
SG and
standard deviation. A
is the same as because the formula
fit ko pa otla mo.
Yeah.
Kidamo. And how na mo ikopanan le mean hey. Le khan. How na mo kan the individual elements be re subtract ka mean be square. Wa bona mo se ko ga ha hona mo ikopanan le mean ti. Next, le box and whisker. Ha hona ka be ka o neyang yona. So why are we saying that? Why are we saying that the mean and standard deviation of a set of data are usually reported together, right? Why should we report them together? Why mean without standard deviation? Yet in a way of calculation, different. Bona mean.
We have to find the mean.
Mean equals the sum of elements starting with the first one. You add that sum again, then you divide it by total number of elements. Arrange. Give me. Marmona standard deviation. Bon. Go born affair. Ntwe fapa na hola hampil ntwe. Mona ungile the sum. Man unkile the first element you subtracted from the mean and then you squared that. That's a huge difference. Very big difference. Yet the mean and the standard deviation of a set of data are usually reported together. Why? Why?
Because they have to find the
Data nyani efitile mplele mean wa haone le bukae. First standard deviation. First the value of
21,32.
21,53. Why must we report the mean and the standard deviation as one? You cannot report the mean without giving us the standard deviation and vice versa. Why? Yet born now it's around. Who guy man is? Hey, mo. Mo.
Standard deviation is always the number.
Our standard deviation is always a positive number. Mbafela you want plus, mona be kill VE. I get that's the short version here positive. Okay. Now we are clicking. I get about when now positive, but we fela plus be by the VE. About to ukisa buhloko. I get about fela osika inkela ka madi. Umnto fela I khutshwane nyana. So re we SD is always a positive number and in the same units as the original data. Maybe how data with the height of children's in centimeters, whatever in meters. Then the standard deviation variance you will always calculate it as that. But variance it has a squared unit. Since the population variance is squared, it is not directly compatible with the mean or the data set the data themselves. But more, SI units more. Standard deviation is always a positive number and in the same units as the original data. But we are not saying the same for variance. Because the variance is aina SI units. And here your variance that's a standard deviation, or it has the same units as the unit of the data that is provided. If your data is in centimeters, you will calculate the standard deviation also in centimeters. But variance, it has got no units. Even in high school many years ago, I don't remember. But if in anything, so come on, how calculate a variance? Well, the units, but how calculate the standard deviation? Got the same units as the data that is provided. Very important. Now, why should we always report the mean whenever we report a standard deviation? Kappa vice versa. How many? Yet more. Doesn't you hold a one thing? Doesn't you hold a hand bit?
how report you never substitute.
No, how report? How to work? In a certain sense, the mean and the standard deviation of a set of data are usually reported together. Usually, how to usually? Come on, someone have a work it's like only something something
The mean and standard deviation of a set of data are usually reported together in a certain
give full stop. Together. Then a rattle.
In a certain sense.
Sense, yes.
Sense.
The standard deviation is a natural measure of dispersion if the center of the data is taken as the mean. Why are they usually reported together? Because you can never find standard deviation without knowing the mean of that data. Never. They are coupled as one. Even the formula, you will never even find the variance osina mean. So the formula itself, it's like the left hand side to equal the right. The mean has to play a central role. That is why Bonalemona ringile as what? The center of every element in your data. Very important that we see such things. Highly and highly important. Formula failure, it just requires that we understand the part. Right, how symmetrically skewness of data, so that we wrap up this entire thing here, statistics. Okay, how symmetrically skewness of data.
What flavor is this?
Hello.
Back in Anuka 15 minutes. What's that 15 minutes? I tshwane la ise letho.
The chunga 15 minutes and I got a lafera symmetrical.
It's a skewness, ne? It's a skewness of data. Symmetric and skewed data. And re buile ka symmetry ke maobane lo. Rare when the data is symmetrical, it simply means it is equidistant from Q2 to Q1 and from Q2 to Q3. I get maobane. Skewness, whether the data is skewed to the left or skewed to the right, and there is a box and whisker.
Meaning, I is skewed to the right or to the left. Yeah, the directly symmetrical value. It's only Q2.
Come on, Q2, it's exactly equidistant from Q1 and Q3. What do? Bona totally it's a
if Q2 we minus Q1,
okay.
we go for a less value than in and how we trade.
How we minus Q3, okay.
If this one is the number, it's
bigger.
It's bigger.
Q3. Obviously it will be bigger. Yeah.
If it is bigger, until Q2 how it's gonna shift to the side again.
What's the major one? I get. I know people already listen to get away cell. Q1, Q3. However, it's symmetrical. Q2 is exactly equidistant from Q1 and Q3. It's symmetrical, exactly in between. However, it's skewed to the right. Q2. Yeah, skew to the right. Again? However, to the left. Yeah.
Space.
For example, for example. Box and whisk.
Yeah.
Kappa, alright. Okay. Renal minimum, renal maximum, renal Q1, renal Q3. Kopa fala mfe value ya mo?
36.
36. Mfe value ya mo?
Q3.
75. Mfe value ya Q2?
54.
Q2 ile kana le 54. Ha re eme pele mo. A ke batla o e ngola mo. Ha re eme fela mo.
The directly symmetrical line in the Q1 plus.
Ha re mahareng Q2. Mahareng a Q1 and Q3. Come on, someone go to Q2. Ile kana le Q1 plus Q3 divided by 2. Aja. Kiman mo to rembo guy. 36 plus 75 divided by 2. Do from guy. 55,4. 55,4. Come on, someone. It is symmetrical. Exactly.
Symmetrical.
Again? It's symmetrical. High level Q2. Equidistant. Q1 low to Q3. But you know, like you tell me one is an limit.
I keep on looking at the
Hey, Mama Mona.
54. Oh, this is the original.
No, originally, how you calculate that in your data set. Again? Mona negabata fela rona re batla o etsa highly symmetrical so that we can compare whether they are skewed to the left or skewed to the right. Right. Now that we fumana of highly symmetrical, give 55.4. Bo rona re fumane Q2 le bokae? 50